Worksheet day 21, still under the interest, annuities, and sinking funds. It said Frank would invest $6,500 each year in an ordinary annuity at Midwest Investments for a period of 11 years at an annual interest rate of 2% compounded at the end of each year. Using the ordinary annuity table, calculate the total value of the annuity at the end of 11 years. So it means he's putting in $6,500 the first year, another $6,500 the second year, another $6,500 the third year, all the way through year 11 he's putting in $6,500 each year, and then the interest rate is compounded at the end of each year. So we are going to use the ordinary annuity table. We're doing 2% for 11 years. So we're going to go over to our table. We're going to look under 2%, and we got to get down to 11 years. Oops, got to put my pen down or it won't like me. So 2% for 11 years means I'm going to multiply by the number, 2% and 11, 12.1687, 12.1687. And so if we go over here to our worksheet, move that back to where we can read it, we are going to take our $6,500 times the number from our table, 12.1687, and then we got to grab our calculator and multiply that out. And so 6,500 times 12.1687 gives me $79,096.55. So if I were to take $6,500 and every year for 11 years put that amount into an account, and it's earning 2% interest each year, I'm going to have $79,096.55 when I'm all done. So on number 2, same kind of thing there. Mark it down. Barbara Lopez invested $4,500 each year in an ordinary annuity at Southern Trust Company for a period of 15 years at an annual interest rate of 8% compounded at the end of each year. Using the ordinary annuity table, calculate the total value of the annuity at the end of 15 years. So an annuity, we put money in every year. Every year we put the same amount in, $4,500, $4,500, and we want to know after 15 years, how much money would we accumulate? So 8%, 15 years. We got to look over here at our table. So 8% for 15 years, 27.1521. So I'm going to write that down, 27.1521. And if we go back to our page, we are going to take our $4,500 each year times our 27.1521. And so if I grab the calculator, 4,500 times 27.1521 gives me $122,184.45. So we would have $122,184.45 after 15 years of putting in $4,500 each year at 8% compounded at the end of each year. So on number 3, again we're doing an ordinary annuity. All of ours have been compounded at the end of each year, so they've all been annually, but we might have something that's compounded at the end of each semi-annual period, or at the end of each quarter, or something like that. So just like on our compound interest table, if we don't have it at the end of each year, which would be annually, and we do it semi-annually or quarterly, we've got to adjust our interest rate and the number of compounding periods. So if I'm doing 6%, but I'm doing it semi-annually, I'm going to look under the 3% column of our table. And if I'm doing it for 4 years semi-annually, I'm going to have 8 compounding periods. So I'm going to look under the 3% and the 8. So if I go to my table, 3%, 8 times, I'm going to write my number down over to the side here, 8.8923. 8.8923. And so when I go over here, again, we did it semi-annually. And so we have $7,500 that we're putting in at the end of each semi-annual period. And we are going to leave that in there for 4 years. So we're going to multiply by 8.8923. And so if I take my calculator, 7,500 times 8.8923 means that I would end up with $66,692.25 by putting it in semi-annually 2 times a year for 4 years. Number 4 says what we're going to do is an annuity due. When you have an annuity due, you put your money in at the beginning of each period instead of the end of each period. So you end up getting a little bit extra interest. So when it's an annuity due, what you're going to do is the same type of thing we did for the annuity, but we have to add an extra period on to get the extra interest, and then we subtract off the extra payment that we really didn't make. So it's kind of crazy. So if I'm going to do $6,500 at the end of each year in my annuity due for 10 years at an interest rate of 2% compounded annually. Again, we're compounding annually. 2% once a year is still 2%. We're going to leave it in there 10 years, once a year, 10 times. But when we do an annuity due, we're going to add that extra month, because we're putting it in at the beginning of each period, and so we have to calculate an extra period in there. And so we're going to use 11 times instead of 10 times. And so if I go to my table, 2% 11 times. 2%, I got to move down a little bit to get to 11 times. 2% 11 times. Again, I'm going to write that down over here. 2% 11 times is 12.1687. 12.1687. So I'm then going to go over here and I am going to take my 12.1687 times that $6,500. So 12.1687 times 6,500 gives me 35,624. Whoop. I got something in there wrong. I better clear that and try my multiplication again. 12.1687 times 6,500. That looks better. $79,096.55. But what I'm going to do, because I wanted to get just the extra interest, is after I've done that calculation, I added an extra month on, I have to subtract off one extra payment. Because I really didn't make the extra payment, I just got the extra month in interest. So if I subtract off my $6,500, then what it's going to be worth is $72,596.55. So on number 5, again, we're going to do an annuity due. We're putting the payment in at the beginning, and we end that extra whatever year's interest or whatever we're working with. In this case, again, it says compounded annually. So Barbara Lopez invests $4,500 each year in an annuity due for a period of 14 years at an interest rate of 8% compounded annually. So 8% compounded once a year. We're still going to use 8%. 14 years compounded once a year is 14 times, but since we're doing an annuity due, we're going to add one, And so we're going to look under the 15 because we need that extra month's or extra year's interest. And so 8% 15 times, if we go over to our table, 8% 15 times, 27.1521. 27.1521. I'm going to write that down over here. So we are going to do 4,500 times 27.1521. So 4,500 times 27.1521 gives me $122,184.45. However, we don't want that extra payment in there. We just wanted the extra interest, so we're going to subtract off one of our payments. So we're going to subtract off of $4,500. And so we have $117,684.45 for the total value of that annuity due. And number 6, again, this one says compounded annually, so I'm going to make it semi-annually just so you have another variation. So Kevin Lee invests $7,500 each year in an annuity due, so paying at the beginning at capital appreciation for a period of 3 years at an interest rate of 6% compounded semi-annually. We want to find out what the total will be at the end of 3 years. So 6% semi-annually means we're going to use the 3% one. 3 years semi-annually would be 6 times, but we're doing an annuity due, so we have to put that extra payment on, so 7 times. So 3% 7 times. We're going to go to a table. 3% 7 times means I got to move up in my table. 3% 7 times 7.6625. 7.6625. So again, we're going to go over here. We're going to take our 7,500 times our 7.6625. So 7,500 times 7.6625 gives me $57,468.75. But we have to subtract off that extra payment that we really didn't make. We just had the extra interest. And so if I subtract off my $7,500, I would have $49,968.75. So number 7 says Janet Hayes wants to receive a $10,000 annuity payment at the end of each year for 11 years. So instead of putting money in, she wants to be able to collect that much money in order to fund the annuity payment. She must invest a specific sum of money. How much does she have to put in right now in order to be able to get $10,000 out at the end of every year for 11 years? The investment will earn interest at the rate of 4% per year compounded annually for the next 11 years. Using the present value of an annuity table, calculate the amount that Janet must invest today in order to fund the $10,000 annuity payment for 11 years. So again, this one says compounded annually, but this table works the same way as all those other tables. We would start by saying 4% compounded once a year, so 4%. I'm going to leave it in there for 11 years, once a year, so 11 times. So I'm going to look at my table under the 4% and 11 times and look for my number. So 4% and 11 times, if I slide down just a little bit. Again, I'm going to rewrite the number over here to the side so I can remember what it is. So 4%, 11 times, 8.7605. 8.7605. So going over to my other page, I'm going to take my 10,000 that I want to get at the end of each year, times that number, 8.7605. So I'm going to grab my calculator. Actually, I could just move my decimal on that one. 1234, 1234 means I'm going to have $87,605. It's easy to multiply by 10,000. I just moved my decimal 4 places over. And so I would have $87,605 that I would need to put in right now, so that after each year for 11 years, I'd be able to take out $10,000. So I'm going to put it in right now, and then every year for the next 11 years, I can take out 10,000, 10,000, 10,000, 10,000, and I would be able to do that. Frank Taylor wants to receive an $8,000 annuity payment at the end of each year for 18 years. In order to fund the annuity payments, he must invest a specific sum of money now. The investment will earn interest at the rate of 3% per year compounded annually for the next 18 years. Using the present value of an annuity table, calculate the amount that Frank must invest today in order to fund the $8,000 annuity payment. So again, this one's compounded annually. It seems like all of them want to be. 3% compounded once a year is 3%. 18 years for once a year, 18 times. So we're going to look under the 3% and 18 times. So in my table, if I look under 3% and 18 times, I have 13.7535. 13.7535 is the value from my table. So again, on this one, we're just going to take that $8,000 that he wants to have at the end of each year and multiply that by the 13.7535. And so 8,000 times 13.7535 would give me $110,028. So I would have to have $110,028 right now to put in an investment so that I can take out $8,000 every year for the next 18 years. Number 9, Sam Gonzalez wants to receive an $11,000 annuity payment at the end of each year for 3 years. In order to fund the annuity payments, he must invest a specific sum of money now. The investment will earn at the rate of 6% per year, compounded annually for the next 3 years. So again, this one's compounded annually. 6% once a year is 6%. 3 years once a year, 3 times. So we're going to look under the 6% and 3 times in our table, which I closed. So 6%, 3 times would be 2.6730. 2.6730, 6%, 3 times, 2.6730. So over on our paper here, I have $11,000 times 2.6730. And if I grab my calculator, 11,000 times 2.6730 gives me $29,403. So I'd have to invest $29,403 today so that I can take out $11,000 at the end of each year for the next 3 years. 10, 11, and 12, they're doing sinking funds. Still using a table. The table works the same way as all the other tables did. Midwest Property plans to raise $600,000 over a 9-year period so they can purchase a piece of real estate. In order to obtain this amount, the company has decided to make annual investments into a sinking fund. So for a sinking fund, you're going to keep putting the money in over and over the same amount that I'm going to put in every year, as opposed to putting one big lump sum in there. So in order to obtain this amount, the company has decided to make annual investments into a sinking fund that will earn 4% per year compounded annually for the next 9 years. Use the sinking fund table, calculate the amount of each sinking fund payment required to raise $600,000 in 9 years. So again on this one, it's got compounded annually. You will have things other than annually, but the computer evidently only wanted to do annually. So 4% compounded once a year is 4%. I'm going to put it in there for 9 years, compounding it once a year, 9 times. So now I need to get my sinking fund table over here. Let's get rid of the present value table and go to the sinking fund table. And so in my sinking fund table, I forgot what I was doing. I was going to do 4% for 9 years in my sinking fund. So I'm going to do 4% for 9 years. I'm going to use that number from the table. And so 4% for 9 years, 0.0945. 0.0945. So I am going to take my $600,000 times 0.0945. And so if I do that, 600,000 times 0.0945 gives me $56,700. So each year, $56,700 would have to be put into my sinking fund so that after 9 years, I'd have the $600,000 in there. I don't know who has $56,700 to put in every year, but evidently this is a big company. Number 11, Southern Land Company plans to raise $450,000 over a 6-year period so they can purchase a parcel of land. In order to obtain this amount, the company has decided to make annual investments into a sinking fund that earns 6% per year compounded annually for the next 6 years. So again, we're compounding it annually. 6% per year, once a year is still 6%. 6 years, once a year, 6 times. And so in my table, I'm going to do 6% 6 times. And so if I look at my table, 6% 6 times is 0.1434. 0.1434. So in this case, I'm going to take my 450,000 times 0.1434. So 450,000 times 0.1434 means I'm going to have $64,530 that I would have to invest each year for 6 years in order to end up raising $450,000. We peek at this one over here. Nope, it is also compounded annually over here. I thought maybe it'd be a little bit different. But just remember on these tables, if it's compounded something other than annually, quarterly, semi-annually, you've got to do what we did on the other tables. Again, this one is compounding it annually. So Cooper & Cooper Development Company plans to raise $675,000 over a 14-year period so they can purchase a new building. They want to use a sinking fund, 4% per year compounded annually for the next 14 years. So 4% annually would be 4%. 14 years, once a year, 14 times. And so in our table, 4% and 14. So 4%, and if we go down to 14, 4% at 14, 0.0547. 0.0547. And so we are going to take our 675,000 times our 0.0547. And so 675,000 times 0.0547 gives me $36,922.50. I have to put that in each year for 14 years in order to end up with the $675,000. But again, keep in mind, for some reason it wanted to be compounded annually all the time. You might have a semi-annually or a quarterly where we end up having to divide by 2 for semi-annually and then multiply by 2 on my years, or 4 for quarterly. And so all of those tables will work that same way if their compounding period is something other than annually. And so that is the end of day 21, annuities and sinking funds, under that interest section of your pie chart.